Hi everyone, this is Pavitra working as an assistant professor in Sri Muthukumaran Institute of Technology. Now we are going to see the lecture on signal processing BM3401. These are the core objectives of this subject, and here the 5 units of signal processing, and today we are going to see about analysis of LTI system. First we are going to see about the Z transform properties. In previous video we have seen what is Z transform and what is Fourier transform. In this video we are going to see about Z transform properties. Linearity property. Ax of n, Ax1 of n plus Bx2 of n is gives Ax1 of z plus Bx2 of z. This is the linearity property. Input should be bounded to the output. Time shifting property. X of n minus n naught implies z power minus n naught x of z. The time shift will be reflected in the output. Multiplication by an exponential sequence. So, this can be written as x of z by z naught. Differentiation of x of z, so n x of n implies dx of z by dz. This is the time shifting property. Conjugation of a complex sequence. Here we will have conjugate x conjugate of n implies x conjugate of z conjugate. Next, time reversal. X of minus n implies x conjugate of 1 by z. This is the time reversal property. Convolution of sequence. X1 of n convolution x2 of n implies x1 of z, x2 of z. This is the initial value theorem. X of 0 equal to limit z intends to infinity x of z. This is inverse z transform. Here we are having partial fraction expansion x of z equal to summation k equal to 0 to m dk z power minus k. Here summation k equal to 0 to n ak z power minus k. This is the partial fraction method. Here we are having x of z equal to summation k equal to 0 to n ak and 1 minus dk minus z power minus 1. Ak will be 1 minus dk z power minus 1 of x of z. This is the inverse z transform. Here this is the second order z transform. Here we are having x of z as 1 by 1 minus 1 by 4 z power minus 1 and 1 minus 1 by 2 z power minus 1. Here we are having z as greater than 1 by 2. This is the ROC condition. So here we are having ROC circle. Region of conversion should be less than of 1 by z. So unit circle is drawn here. Here we are having partial fraction method solution. Here this will be come under a1 by 1 minus 1 by 4 z power minus 1. This will be come under a2 by 1 minus 1 by 2 z power minus 1. So solving this we will get the value a1 a2 and substituting a1 a2 values in x of z. This is the partial fraction expansion. Already we have seen in previous slide. This is x of z equal to r equal to 0 to m minus n dr z power minus r plus k equal to 1 to n ak by 1 minus dk z power minus 1. Again solving this we are getting again additionally Cm value. This is a Cm equal to 1 by this value For multiple order poles, we will have this equation. This is the multiple pole order partial fraction method. Here we are having x of z equal to 1 plus z power minus 1 the whole squared by 1 minus 1 by 2 z power minus 1, 1 minus z power minus 1. Here we are having 1 plus z power minus 1 the whole squared. So 1 a plus b the whole squared equal to a squared plus b squared plus 2ab. So we are writing this as 1 plus 2 z power minus 1 plus z squared. Again we are putting in partial fraction method. So we are having b naught plus a1 divided by 1 minus 1 by 2 z power minus 1. Again this is a2 by 1 minus z power minus 1. Here b naught is given by z power minus 2 divided by 1 by 2 z power minus 2. So b naught will come as 2. So using this we have to find a1 and a2 values. So after finding a1 and a2 values, we can directly substitute these values into the x of z. So finally we will take inverse that transform. So we are having x of n equal to 2 delta of n minus 1 by 2 power n u of n plus 8 u of n. This is the partial fraction method solution for z transform. Thank you. For more videos, please subscribe Sri Muthukumaran Institute of Technology YouTube channel. Thank you.